We're going to discuss the problem 37 one about cereal. We talked about this a little bit in class, but what I want to do is just kind of break it down and go through the whole thing and make sure that we understand how to come up with each part. So the first question was just about mean and standard deviation. However, if I don't know what the difference is, or if I don't know what distribution I'm looking for, then I have a problem with that. What you're looking at here is it wants to know at the end, that the very last part that says how much more is in the large bowl than in the small bowl. That's your indication of exactly how to identify what are you looking for. In this case, what we're going to be looking at is literally the difference, and you can see that here, right? I'm trying to find the difference between the large and the small. So that's going to tell me the amount left over. It's about as more straightforward as you can get. Anyway, so we're going to be able to create a distribution saying large bowl minus small bowl. So that's how we're going to find our mean, our standard deviation, based on maybe you used X or Y or L or S, but it'll be L minus S, or in this case I'm going to use large minus small. And that's exactly what we're going to go through and find means and standard deviation and create all of them there. So if we kind of break this down, it looks pretty straightforward right here. You've got, I wanted to find the expected value. How much would I expect to be in the large bowl minus the small bowl? And it would be just the same. If you remember expected value, it works just like any straight formula. I really just plug the numbers in. So we'd say, well, if I expect to have 2.5 ounces in the first one and 1.5 ounces in the second one, if I subtract them, that leaves me with an ounce. Expected, right? If we look at standard deviation, I'm really just plugging these things in. It would be the variance of the large plus the variance of the small. Remember, always add variances. This is very important. Notice that's plus. Even though over here it says large minus small, we always remember that that variances are always going to subtract, are always going to add no matter what you do. So we plug that in, or you're going to get 0.4 squared plus 0.3 squared, which gives me my half an ounce or my 0.5 ounces. So that's mean, that's standard deviation. If we keep going, the next part is basically going to be looking at our mean and our standard deviation for each piece. So what I wanted to do was take a second and talk about the normal model and using what we have as our defined mean and standard deviation from our previous example. And so if we want to look at this curve, what we can do, I'm going to go ahead, I'm going to draw the curve in. And so if we have, let's see, let me put it right here. So we're going to label our normal distribution. Now what we're looking at here is the questions. So our mean, which we'll go ahead and label that in here, we'll put that right there. The mean was, of course, 1 ounce. We had our standard deviation. I'll label that over here by the side. Standard deviation was equal to my 0.5 ounces. So what we're going to figure out is, well, if 1 is here, the question says, what is the probability that the small bowl contains more than the large bowl? Well, if you look at our distribution, we have large minus small. So we want to know when this distribution, if this number was larger, what would happen to this distribution? Or if I said, let's say the large bowl has its average 2.5 and the average 1.5 here. So if I subtract that, I get 1 ounce. But what would have to happen in order for this whole thing? What would it do if the small one had more than the large one? Okay, the answer to that question is that if I did the subtraction and the second number was larger, then that would make this whole thing negative. So what we're looking for is what's going to be, I want to know when that's less than 0. Right? And so if we look this up, that's going to allow us to find out exactly what the probability is. And so if I go back to my curve, and I find out where is 0 in the case. So, right, so it's actually 2 standard deviations below the curve, and so 0 would fall in somewhere right around here. So we want to know what is the area shaded right there. So our mathematical operation, if we kind of take that curve, we use normal CDF, and that's how we find our probabilities. And so we're going to write the normal CDF is going to end up being like this. Well, we're going to, it's a less than problem because everything goes to the left, so we're going to have our minimum value to be -1 E99. We're going to have that go all the way up until it gets to 0, and the mean of that distribution is 1, my standard deviation is 0.5. Work that out, and it's going to give you approximately 0.023. And there we have it. In order for me to do the normal model, I had to figure out what the actual mean and standard deviation of this situation was. Right? So I go ahead, put that mean down, put the curve down, and I use my normal CDF based on whatever I'm looking to find. Alright, let's go on to the next part. So the list at this point is saying, alright, let's change it a little bit. What if we said we want to combine the bowls? What about the large with addition of the small? How much would that be? Alright, so they're changing the differences. We're not looking at the difference anymore. They're changing it to the sum. And so if I actually take that, my distribution would change to this one, large plus small, and that would equal my total amount. So that means I have to recalculate all the mean and standard deviation again, look, which doesn't mean I have to do a whole lot of work, but it goes back through this process. And that turns out that if I were to combine the bowls into, say, a separate third bowl, then that would average to be about 4 ounces. I would expect that size to be 4 ounces. Come back over here. The standard deviation of the large bowl minus the small bowl, actually that should be plus. Let me adjust that real quick. All right, so that would be plus. And so we go here. You see the variance. Notice the variance. So it's plus here because we're adding we're trying to find the actual sum from up here, right? But if I come back to this part, what do we have here? We have the large plus the small. Remember, even though this one's plus, but last time we had minus, it was still plus. This always stays plus. So we go back over to our different values. We can see that we have 0.04 or 0.4 times plus 0.3 squared, which still gives me 0.5. That didn't change. Plus, if I do the sum or the difference of the variances, it's still going to be the sum, so that one stayed the same. Okay, remember that's why the standard deviation didn't change. Now this time, we're changing the question again. So if we're looking at part D, it says it's kind of following into part E. If the total follows a normal model, what is the probability that you poured out more than 4.5 ounces of cereal into the 2 bowls combined? Right, so let's go back to our curve. So if we draw the curve again, so we have our normal model here. Our mean this time is 4 ounces. My standard deviation stays as 0.5, and up here we have 4.5. Now this should ring a bell, because what we've done is we've just simply went up 1 standard deviation. So if you remember your 68, 95, and 99.7, you can actually get to the answer, and it's going to be about 16%. Right? So I really don't have to use normal CDF, but let's go through the process again. So it'll be normal CDF. This time it's going to be, I'm starting at 4.5, and we're going to go all the way up, so 1 E99, because I'm greater than this time. And the distribution's mean is 4. The standard deviation is 0.5. When I'll allow that to kind of work its way out, whether I use the empirical rule or I use normal CDF, we're going to get 0.159, or if you use just the empirical rule by itself, you had gotten 16%. Either way, if your explanation included that as your explanation, you would get credit either one. But remember, it's asking, the question itself in part E says, if the total amount follows a normal model. That's kind of leading you down the road. Here's a normal model. I want probability, right? That is key words for use normal CDF or use the z-table to find out the area under the curve. Okay, let's go on to the last part. Here, back in part F, now this is the part where it gets a little tricky. It says, what if you added the original box to the problem? And so, well, what if we had the box, and I'm going to remove 2 bowls of cereal, one large bowl and one small bowl. I've got to figure out what kind of distribution they're talking about. I've got to figure out how to get the mean and standard deviation again, and it's just like it sounds. If I were to take the box and then subtract out the large bowl and the small bowl, that would be the amount left in the box. And so here again, if you can rewrite this with letters. I use the words just to make it simpler. And so box minus large minus small would be the exact value. I would want to say, what's the expected value that's going to be left over in my cereal box? So if you walk through that, you've got the box minus the large minus the small, and that result would get you about 12.3 ounces I would expect to be left on average in the box if I poured out these 2 bowls. Standard deviation works the same way, right? It's all, even though it's minuses here, it doesn't matter because they're plus. So you add all the standard deviations together, work it out, and you get the new standard deviation to be 0.54. Now, I could even take this further. What if they said, what's the probability that you would have less than 10 ounces of cereal left in the box after pouring these 2 boxes? Then you could go to be less than, and you use the mean and the standard deviation that we just found to calculate those 2 values. Okay, let's do the next question. All right, so this is coffee and donuts. We did this, or we did part of this in class. I wanted to kind of re-emphasize this so you could have it to look at. So the coffee notes, I'm not going to talk about part C, not today, especially just primarily because of time, and I'm not really going to give that kind of question on the test, so no worries about it. Part A says the shop's open 6 days a week. We want to find out what is the probability, or what would be the average, the standard deviation of the number, or the number of coffee cups that we would sell in that given 6-day period. So what we have to figure out is, well, means add just like normal values. Standard deviations don't. I have to add the variances. And you can see here in our work, I wanted to find the expected value for the cups of coffee for 6 days. Well, that would be like having the same thing 6 times, so we're just going to shorten that by saying 6 times whatever it would be for 1 day, and that gives me my 1,920 cups. Standard deviation, here again, it would be just for the 1, and then multiply by 6, because it's the same thing 6 times. So we find the variance, which would be 400, and then I'm going to multiply that by 6, and then square root that value. That's where we're going to get our 48.99 cups. Now, next part would be we can plot our mean and standard deviation and shade the curve. And the question was, okay, so if my average with that was 1920 and my standard deviation was 48.99, what would be the probability for getting 2,000 cups? So we come back in, we draw this little curve. You put your mean down, you put your standard deviation. So my mean was 1,920, so 1,920. My standard deviation for the problem was going to be 48.99, and they wanted to know, so somewhere up in here, probably something like this, probably pretty small. Here's 2,000. If you look at that, you think, okay, well, 48, so I'm not quite 2 standard deviations up. It's only, if you look at the value, we're at 1920, right? So that's 80 units to get up here. So it's not quite 2 standard deviations. So it's not completely out of the question, but we could work that out. And so if you look at it, you can find your normal CDF. We come over here, we can write that out. So your normal CDF would be starting at 2,000. You're going to go up to 1E99, just a really big number. The mean of 1,920 with a standard deviation of 48.99. Now, if you used 49, is that a big deal? Probably not. At least not for this particular example. But they left it like this, so I'm good with this. So once you type this in to your calculator, you're going to use all the values that we looked at here, and it should give you a probability that you would expect not to be too crazy. because we know that it's not 2 standard deviations away, so that shouldn't be surprising to us when the probability is relatively, it's small, but it's not it's not crazy out of the question. So when we look at it, the probability turns out, so the probability that your x value, the number you're looking at, is greater than 2,000, turns out to be about 0.051. So just slightly more than 5% of the time. So would you say this is unusual? It's not crazy, but if somebody told me this and they acted like it was no big deal, I would have something to do with that. I would think, I don't know if you're going to get 2,000 cups in one 6-day period. Right? It's not very likely. It might happen occasionally, but in this case, our results said it should only happen just maybe 5 times out of every 100 weeks. So that means if you have it 50 weeks, you're looking at maybe 2 or 3 times a year that you get a week that you sell 2,000 cups of coffee. All right, so let's look at the next part. Here in part B, it says the money that we charge for a cup of coffee was 50 cents. That would be great. That's not going to ever happen these days. The donut cost 40 cents. If we wanted to figure out not the definition, but the expected value, how much money would you expect to make on any given day, according to your mean and standard deviation, would be right here. So we can plug that in. Here it's kind of like a cost function or a profit function. You know, if you remember back from back when we did algebra, not us, but in other classes. And so you would say, well, it would be 0.5 times C plus 0.4 times D, the number of donuts, the number of coffee cups. And we just basically plug our mean in to find the average. We do the same thing as we did last time to find the standard deviation. So this time I'm multiplying by a constant. Remember here, I'm multiplying by a specific number. That means that when you go to find the standard deviation, you're going to have to square that number as well as squaring the standard deviation so that you can find the variance, and that's just kind of this one part here, the 0.5 squared times 20 squared. This is the variance for this distribution, the 0.5c. I've got to do the same thing for 0.4d, and you can see that over here. I square those values, we square root at the end, and we get $11.09 will be my standard deviation. All right, so if we go back in, finish this up, we're going to say, what's the normal CDF, or what's the probability that you could make over $300? If you're really quick, you see $11.09, and you think about, well, here's my mean of 220. If I'm talking about standard deviations, $300 is incredibly far. It's between 7 and 8 standard deviations above my mean. So automatically we know, because it's normal, this is not ever going to happen, or it'd be extremely rare. So let's just kind of look at how the curve would be. So here's the mean. We'll say that's our 220 standard deviation. And so if we wanted to figure out what this probability would be, I mean, personally, I think that this would be a complete overkill. You don't need to do this because you know how far away it is in terms of standard deviation. And so that wouldn't make any sense if I wanted to figure out what's the area above that particular value. It's going to be 0. And so if we type this in our calculator, let's see what it gives us. I mean, it gives us something crazy like 2.7 times 10 to the negative 13th. So let's try that. So 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's the probability. So if we round to a reasonable estimate, that's 0 on any reasonable scale. And so I'm not even going to shade it because that's so far down the line, it's not even on the part that I drew. But it would be extremely small. And I use my normal CDF. I'll write that in, normal CDF. And I typed in, if we were at 300, and I want to do greater than, this would be 1E99. And I went all the way, and we did use the 220 mean, and the $11.09 as the standard deviation. And that would be my result. Okay? So I've taken way too much of your time already. So here's 2 examples. If you have questions, please feel free to email me and let me know if you have any other concerns.